Hello students, I hope that you are good, well and fine. Today we will be continuing our discussion on the topic of trigonometric functions. In previous lecture, I have discussed the basic concepts. In order to know about ITF, we will know some idea about these basic concepts. Okay, and then we discuss the sine inverse function and then the graph of sine inverse function. Now in today's lecture we will be seeing about cos inverse function and the graph of cos inverse function, cosec inverse function and the graph of cosec inverse function. If time permits, we will be covering other topics also. Okay, so let's see the cos inverse function. As we saw, or as we know, what we know, to get an inverse of a given function, the given function must be what 1 1 and onto. Then only we can find inverse. Okay, so in cos x we know the graph. If you see the graph for cos x, the graph of cos x looks like this. And from this graph, if you perform horizontal line test, you can see that it is indeed not 1 1. In order to make it 1 1 and onto as well, as what we will do? So first of all, the cos x is from where, if you recall, the r to minus 1 to r. But we need what? 1 1 and onto. So this means we will do some manipulation in the domain set. So if so making the domain just where to where? This 0 to pi. If cos x is defined from 0 to pi, and the codomain remains the same, minus 1 to 1, then my cos function will be what? 1 1 and what? Onto. As you can see over here from this diagram, it is 1 1 and onto. And this means that now I can talk about the cos inverse function. So the cos inverse function will be what? Cos inverse will be from where to where? Minus 1 to 0 to pi. Okay, so this will be my what? Cos inverse function. Yes, and if you try to plot it, so let's plot the cos inverse function. So plot cos inverse function. So what we know, first of all, cos 0, if you recall, this is my graph, this is the value at pi and this is the value at 0. So cos 0 is 1. What this means? This means cos inverse 1 will be what? 0. Okay, cos pi by 6. Cos pi by 6 is what? If you recall, cos pi by 6 is root 3 by 2. So this means cos inverse root 3 by 2 will be what? Just pi by 6. Yes, cos pi by 4 will be what? You remember, if you recall, cos pi by 4 is 1 by root 2. This means cos inverse 1 by root 2 will be what? Pi by 4. Okay. Cos pi by 3. Cos pi by 3. What this equals to cos pi by 3? Cos pi by 3 is 1 by 2. What this means? This means that cos inverse is what? 1 by 1 by what? Say 1 by 2 is equals to pi by 3. And cos pi by 2 is what? Cos pi by 2 is 0. We all know that. So this means cos inverse 0 will be what? Pi by 2. Now try to plot graph for it. Okay. So what we know, first of all, cos inverse is from where to where? Cos inverse is from 0 to cos inverse is from -1 to 1, going to minus 0 to pi. Okay. Now it is from -1 to 1. Okay. As you can see, at 0 it is pi by 2. At 0, so let's say here is my pi by 2. So this here is my point pi by 2. At 0 it is pi by 2. At 1 by 2 it is what? Pi by 3. It is what? Pi by 3. So pi by 3 will be somewhere here. Pi by 3. Let's say now at root 1 by root 2. At 1 by root 2 it is pi by 4 somewhere here. At root 2 pi by 4 somewhere here. Pi by 4 and pi by 6. At root 3 by 2 it is pi by 6, and at 1 it is 0, like this. So my graph looks like coming downward like this. And if you see, if you plot for some here, for example, for -1 by 2, -1 by root 2, you will see your graph will look like this. Okay, your graph will look like this, and at -1 you will get what? The value pi. You will get the value pi. Okay, so 0 to pi. As you can see, your rough diagram will look like this. And if you get some observation, you will be observing that if your graph, this graph looks like this, as you can see, left to right, but in this way, your inverse graph is looking like this. Yes. So as you can see like this, as you can get the idea that your actual original graph is going from left to right, but also in decreasing manner. As you can see, in decreasing manner, then your the inverse graph is also coming from up, not up to down. As you can see, up to down in decreasing manner. Up to down is already in decreasing manner. Okay, so decreasing manner, as you can see over here. If you recall, the sign was like this in increasing manner. Yes, in increasing manner, and the sine inverse graph was looked like this in increasing manner. Yes, down to up. So down to up, left to right is what? In increasing manner. So increasing manner is down to up, and left to right is decreasing, means up to down. We will have to go up to down. As you can see that it is looking like this, up to down. Yes, I hope that this gives you some easy way to recall these inverse graphs. Okay, so now this range, what we called it as the principal value branch of cos inverse. If you recall, the sine inverse, what? The sine inverse is defined from -1 to 1 to minus pi by 2 to pi by 2. And okay, this. And the interval, we always seeing the principal value branch whenever the function is 1 1 in the specific interval. So the sign is 1 1 and onto in this interval. That's why we said it is the principal value of the cos inverse, sorry, the sine inverse. In here the cos function is 1 1 in this interval, so this means 1 1 as well as onto. So that's why we are saying that it is principal value branch of cos inverse function. Okay, always remember that the 1 1 and onto, wherever the original function is 1 1 and onto, we will be calling it as the principal value branch of the inverse function. Okay, so let's move to next. Now as you can see, the graph from 0 to pi is this, the 1 1 and onto. The inverse for this is like this, as you can see over here. Yes, so left to right in decreasing manner will be decreasing manner also here. So up to down, up to down. Okay, as you can see, up to down. The topmost point will be pi, and the say this point will be what? 0. Okay, okay. I hope that now you can easily make the cos inverse function without any facing difficulties. Okay, let's move to next for cosec inverse. What? The cosec inverse, if you recall, what? The cosec inverse graph. Cosec, if you recall, the first of all cosec graph, we know cosec graph we can easily make from sin x. So first of all make sin x like this. Now what we will do is these as make asymptotes. Now make parabolas in between asymptotes like this. Okay, okay, this is my what? The cosec x graph. Okay, now what? Now in order to find the cosec inverse function, we need my cos x to be what? 1 1 and onto. So in which interval I can make it 1 1 as well as onto? So if I restrict my graph from, so as you can see, this is what? The 0. Okay, this is what? The pi. Yes, pi. Okay, and this is what? The minus pi. Minus pi. Now what? This point is my pi by 2, and this also my minus pi by 2. Now what? If I take this part, only this part, as you can see, as you know, this is 1, this is minus 1. If I take this part and this part, okay, this part, now in this part my cos x is what? My cos x is what? 1 1, as you can easily see that 1 1, and cosec x is, I am taking the interval minus pi by 2 to minus pi by 2 to 0. I am excluding 0 because at 0 it is not well defined. Union 0 to the open interval 0 to pi by 2. Okay, from this to where, as you can see, minus 1 to, so minus, as you can see, it covers minus infinity to minus 1 union 1 to infinity. So the codomain I am taking it as this, and domain I am taking it as this. Now it is 1 1 and onto, as you can see, the cos inverse cosec inverse function will be from where to where? Minus infinity to minus 1 and union 1 to infinity. Okay, 1 to infinity to minus pi by 2 to 0 open interval union 0 to pi by 2. Okay, I hope that it is clear how we are taking these intervals. So this will be what? My principal value branch, because in this specific branch this becomes what? 1 1. Okay, as you can see that the cos inverse function is now defined from, okay, is now defined from the R eliminating -1 to 1 interval, or in other words this thing. Okay, so cos inverse is defined from this. So cos inverse is this, as you can see, and the codomain is this, as you can see over here. So minus pi by 2 to pi by 2, including minus pi by 2 and pi by 2, but excluding the 0 points. Okay, so this is same as, don't confuse with my notation, and this is same as this one. Okay, so this is closed, and this is same as what? Minus infinity to minus 1 closed interval union 1 to infinity. Okay, so the principal value branch will be what? This one. Okay, don't confuse with it. Now what will your graph look like? As we know, the cosecs we define from this to this. Okay, cosecs we define minus pi by 2 to 0 and is open interval 0 to pi by 2 closed at pi by 2 as this. So how will you find? Either you try to find out the values you will find, or just do what? As you recall, whenever you want to plot your graph for inverse function, you always try to make first of all the original function, and then try to mirror the graph with respect to this line. So if you mirror, if what will happen if you mirror your graph with respect to this line y is equals to x, what you will get? You will get that this point will be like this, something like this. Okay, this point will be like this, as you can see over here, this. Okay, so this. Okay, and this will be something like this. This will be after you see the reflection or the mirroring image will be like this. So as you can see over here, your final cosec inverse graph will be looking like this one. As you can see, the red one I marked, just ignore the other part. This is the one. Okay, so after reflection, so let me use different color. After reflection, this will be like this, and this branch will be like this. Yes, yes. Okay, I hope that it is now clear to you. So I hope that now you can easily recall or can make the cosec inverse function. Why we are mirroring with respect to this? Because if you recall, in relations R is a relation, then the set of R will be what? The pairs. Okay, pairs. And the inverse relation, the pair will be what? BA. The points get interchanged, B to A to B. So that's why we are mirror imaging. Okay, mirroring the graphs. Okay, now what? Now let's move to next function, which is sec inverse. Okay, let's try to analyze it. So sec, first of all, let's understood the sec function. If you recall, sec x is 1 upon cos x. First of all, let us make the graph for sec x. For sec x, we all know we will always start with the cos graph. So cos graph is this. Now what? We make asymptotes wherever the cos is 0. Now what? Now we make parabolas like this. As you can see, the cos inverse is this. But we want, in order to find the sec inverse x, we want the cos inverse to be what? 1, 1 and on 2. So I'm taking what? So just taking the interval where my sec x is 1, 1 and on 2. So this is what? At say pi by 2 and minus pi by 2. Yes? Yes. And pi by 2, and this will be what? 3 pi by 2. Okay. Now what? Now this is what? 1 and this is what? Minus 1. So I'm taking just this part. Okay. I'm taking just this part of the graph and this part here. Okay. Now it is quite clear that because the sec x is from where to where? Now it is from 0. So here it is 0. So 0, the closed interval 0. So 0 to where? Say pi by 2. 0 to not say it is pi by, sorry, pi. So 0 to pi, but excluding the value pi by 2. Yes. And it is going to where? The minus 1, or say the r minus open interval minus 1 to 1. Okay. And your sec inverse will be this. Okay. I hope that it is quite clear to you what is happening. So as you can see, your sec inverse is r minus 1 to 1 interval, open interval, and then 0 to pi closed interval, but except the point pi by 2, as you can see over here. So this will be what? My principal value branch. As you can see, this will be what? My principal value branch. Let's see the graph, how you will look the graph of it. So first of all, let us try to make a rough graph. Okay, so what you will do for rough graph? Just do nothing. Do just this thing. If you try to do mimic or mirror the graph with respect to this, what you will get is quite easy. This point will be in somewhere here. Yes. And this point will be somewhere in this second quadrant. So I think what this will be like this, and this will be like this. Okay. Okay. So mirroring, what you will get is quite easy. Let me show you. Okay, so that you don't get confused. So we took what we took. We took this part and this part to make my function, this function sec x 1, 1 and on 2. And then we will be talking about the inverse function now. On taking this, what you will get, that this will be here, as you can see over here. Yes, like this. And this on mirroring, you will get this mirror in this quadrant. So you will get this point like this. Okay. I hope that now you can easily make graphs. Okay. As you can see, it is what? Pi. So here it is also pi. It is pi by 2. It is also here pi by 2. This line is what? Pi by 2. Here is pi by 2. This is what? The point 1. Here also the point 1. It is approaching to the infinity, as you can see over here. So here it will going to the pi by 2 till it gets increasing and increasing and increasing. But here what is happening? Whenever x gets keep increasing at x is keep increasing, you will get closer to what value? Pi by 2. In here, if you kept x near to pi by 2, then you will get that the value sec x keep high, very high, very high. This means high to infinity. But here sec inverse x will be closer to pi by 2, as you can see. So opposite is happening, just nothing. Okay, here sec x is going to infinity, but x is going to pi by 2. Here x is going to infinity, but sec inverse x is going to pi by 2. Okay, just the vice versa. Okay, so I hope that you understood the things over here very clearly. Without any issue, you can make any graph for say the inverse graph for sec inverse x. Okay, so let me recall you once again what. For sine, we know we took this. The graph was like what? If you recall, can you recall? Sorry, the sine function, the sine, let me clear the board. So functions, okay, so let me use sine. So sine function, if you recall, looks like this. 1, 1 and on 2 in this interval. The interval was the principal interval minus pi by 2 to pi by 2. And then the inverse function, the sine inverse function, looks like what? If you recall, looks like this. Yes. And here it is from minus 1 to 1. And this is from what? Minus pi by 2 to pi by 2. This is for sine. This is minus 1 to 1. Now, for cos, if you recall, cos was from this 0 to pi, and this 0 to pi, and this point was 1, okay, 1, and this was minus 1. And your cos inverse was from minus 1 to 1 to 0 to pi. Yes, minus 1 to 1, sorry, yes, minus 1 to 1 and 0 to pi. And your cos inverse was looked like this, if you recall this. So from this, if you see that here your graph looks like this, and from here your graph looks like this. Okay, so left to right increasing, down to up increasing, left to right decreasing, up to down decreasing. Okay, and this is from where to where? Minus 1 to 1. This is what point? If you recall, this is pi by 2, and this will be what? Pi. Okay, now what about the sec? Now sec x. If you recall the sec x, we just did the sec x function. Okay, we just did the sec x. Okay, so let's just recall for sec x quickly. So this was our sec x. Okay, so what we did, we took this part, and then we mirror image it with respect to y is equals to x. What we will be getting? This part. So that's it for today. Thank you. We will be meeting next time. Thank you again.